Team Lit presents Advanced Spacecraft Lighting Control System.
Traditional lighting systems in spacecraft offer only one constant setting. The continuous bright white light confuses the crew members' biological systems into thinking it's daylight all the time. The body starts to feel stressed. Certain hormones aren't releasing while too much of another hormone are releasing. This internal mechanism is called our circadian rhythm. Our senior design team proposes a solution to optimize the current lighting system's ability to maintain the circadian rhythm for each of the crew members. My name is Farhan. I am the team lead, front-end designer, and hardware specialist. We have Simmer. She is our back-end software specialist. We have Shafi. He is our algorithm specialist. We have Shitij. He is our network specialist. And we are Team Lit. Our motto is to keep it lit. Our teammate Shafi will start with our objectives in the next slide.
Thank you, Farhan. Let's recap our objectives to our project. 1. Circadian rhythm cycle, to maintain the circadian rhythm for each crew member. 2. Plant and vegetation cycle, to provide a two-stage plant growing routine. 3. Logging system, to restrict any unauthorized access to the system. 4. Color correction, to detect and attempt to correct any color degradation. 5. Light intensity, to maintain the light's brightness. 6. Voice command system, to change the light settings with a voice command. 7. Graphic user interface, to increase usability. Our teammate Jatij will walk you through our overall system design in the next slide.
Thank you, Safi. We have our overall system component design for the project here on the slide. The user interface will be used to control the system. The server uses a SQLite database to store all the data. The voice control uses an ARRI speaker, array microphone to listen for the voice commands. The networking interface uses a router to link the entire system. Raspberry Pi for controllers are used all on the lights and the main console. DMX lights are used to illuminate the light zones. A custom PCB was designed for the sensor system. These are the main software we use to accomplish our project. Now Simmer will dive into the implementation behind the design.
Thank you, Jatij. Let's talk about what's happening behind the scenes here, shall we? How is the circadian being maintained? For this, I would like to ask my teammate Shafi, the algorithm specialist, to give us some idea.
The circadian cycle takes in the time zone that the user configures where the lights will adapt throughout the day according to the expected color schedule.
Thank you, Shafi. Let's see what's next. How is the growth and bloom cycle working? This also calls for our algorithm specialist, Shafi.
Our growth and bloom cycle for plants and vegetation follows the same principle as the circadian cycle with a different color schedule. However, the user has the ability to select the colors for the day and night as well.
Thank you, Shafi. Now, how does the autocorrect system work for color degradation and light intensity? For this, I would like to call our backend software specialist to answer. Whoops, I guess that's me. Our color degradation and the light intensity correction system occurs at least once every hour. It utilizes the color sensor system, which includes an RGB color and lux sensor, to compare the sensor values with each expected value. An attempt is made for an adjustment if there's any significant variances between the values. The system also notifies the user if there's any error. Now that we have some idea about how the behind scenes work, let's look into the front end. Starting off with how does the dashboard and the login is being implemented. I would like to call our front-end specialist, Farhan, to tell us about the dashboard. But before that, let me cover the login part real quick. To access the dashboard, the user must register to be able to log in. There's also an administrator who has the privilege to delete user, grant users to become either an admin or technician, otherwise all the users are general users. Now, let's ask Farhan about what's inside the dashboard.
The dashboard allows the user to monitor and control the zones. There is a diagnostic panel that is available to the admin and the tech users to be able to perform reboots of the zones, system updates, and access usage logs.
Thank you, Farhan. We can't forget about how the voice command is working, can we? Let's call our network specialist. Hey Chitij, how is the voice command working?
The voice command system listens for a command where the server processes the command to generate an intent and will perform the action requested.
Thank you, Chitij. I know this slide was a lot of information to take in, but it was an imperative step before the next slide. The next slide will give you a visual demonstration of our system.
Hi there, we're Team Lit, and today we'll be demonstrating our lighting control system. Let's take a look at the parts that we have today. Each of our zones features an LED light, and it's controlled by a microcontroller that's mounted to each of the lights. And it's utilizing a USB to a DMX converter, and all of the lights communicate through our router system here. Let's take a look at a live demo. I've already pre-wrote the credentials. I'm just going to hit login here. And we're going to see this actually takes us to an admin panel. And we can see all sorts of different users that are able to access the system. We can go to the dashboard. And we're greeted with a welcome screen. This is the main command center. We're able to see which of the zones are connected to the system. We have a fun little time clock here. We can sign out of the system, and there's even an emergency shutdown feature. Let's interact with one of the zones. Let's turn off the room lights. So I'll select the menu from here, the navigation panel, and we're going to just pick one of the zones. And the first two presets is going to be to maintain the circadian rhythm for our crew members. And then the second two presets will be a two-stage plant cycle. Let's take a look at what me and Joe Green can do. Let's pick a growth cycle.
Adjusting lights to growth cycle.
And then we even offer a manual control system if the user needs to override the system. They have the ability to do so.
Adjusting lights to warm white.
Now let's take a look at the voice command system. Hey Jarvis, change the lights to circadian 1 for Nora.
Adjusting lights to circadian. Crew member A.
Success, it works. Thank you for joining our presentation today and demonstration.
Now, wasn't that lit? Thanks, Farhan. To conclude our results, we have a GUI created with the hash logging system, admin, and diagnostic panel, referred to as the Lit Command Center. All the lights in the local network used OLA to transmit DMX signals, a routine to maintain the crew members' circadian rhythm, a custom PCB for sensor system designed, prototyped, and manufactured, referred to as the Lit Detector, a voice command system created, referred to as the Lit Commander. A plant environment was used to grow tomatoes and mustard plants using the plant lighting routines.
For the future development, we envision additional features that can be added, such as voice recognition, motion sensing, as well as email notification to enhance the usability of the system.
We would like to take a moment to acknowledge Dr. Tim Urban, Ms. Talia Jurgens, Mr. George Salazar, Dr. Robin, our lab manager Alejandro, and the Department of Computer Science and Engineering at UNT for providing us with this opportunity. These are our references.
Thank you.
Thank you.
you.
We will now be taking questions.